Hello, short video about the benefits of ferrite beads or ferrite rings. I've got a couple of clip-on ferrites, and the disadvantages of buying cheap non-Yaesu in this case accessories. This microphone actually came with this radio. Gone out of focus. This microphone actually came with this radio. It's not the standard one for it. When I bought the radio secondhand, it came with this microphone. And with use, I've noticed that I get erroneous signals. You can see now that is end stopping. When I unplug the microphone, it's gone. When I plug the standard microphone in, I bought a standard microphone. I bought a new MH31. So if I plug it in, are we two here? Let's have a look. If I plug it in, we don't get any issues. Hunky dory. Yeah, fine. Unplug it. Still nothing there. Plug the... Now, whether or not it's coming from the circuitry that runs the LEDs, I don't know. I doubt it's coming from the LEDs itself, because LEDs are, well, they're quiet. I mean, there's an LED there. When I key the microphone, it goes to red. On receive, it's green. That's an LED. So that's not the issue. It could be something to do with circuitry inside. It could be a little voltage regulator or something in there. I don't know. I've not taken this microphone apart. But anyway, as you can see, we've got a 9+. If I unplug it, it's gone. It's a strange one. So I don't use this microphone very often. But the benefits of ferrite rings. So we shall clip a ferrite ring on. Let's have a look, see which ones I've got here. So this is the first one. I'm not sure what mix they are. They're just a bog standard ferrite ring. I've got quite a lot of ferrite rings, ferrite beads, those sort of things. So we'll clip it on and see what happens to the signal. So yes, it's gone down. It's gone down to a 9. We shall take it back off. And there we go. It's back up to a plus. S9+. Put the ring back on. We're down to a 9. Okay. So good so far. Let's put another one on, see what happens. We're down to an 8. At this rate, we're going to need about, well, we're going to need about 9 of them. So let's put another one on. 7. Yeah, so each ferrite ring knocks it down by 1 S point. So we're going to need a few more. In fact, we're probably going to need a load of them. But anyway, as you can see, the noise level is actually going down when we put a ferrite ring on there, or a ferrite bead. So I take this one back off. It should go up, and it does. Take this one off, and it does. Okay, let's move it to this side of the microphone and see what happens. I really didn't do anything on this side. Definitely there. Moving the microphone about a bit does alter it. As you can see, it's gone right up. That makes no difference on this side. Definitely this side here. And it's got to be closed. It's no good if it's only partial. It makes no real difference. It's got to be closed. So you can see as we start closing it, it'll start to drop. There we go. I think my hand is affecting it a bit, maybe. Yeah, maybe just a bit. It's not the power lead. If I unplug the power lead, that makes not much of a difference. I said my hand near it does affect it. But if we unplug the microphone, it is gone. So there we are, the benefits of ferrite rings. Let me see if I got a ferrite bar. I'll push a ferrite bar up through the lead now, if I can find one. Okay, so I've just had a search around in my junk box, and I've got a ferrite bar. This is a piece of ferrite. It's basically the same sort of stuff that's in there, but it's in a bar form instead. This is well, I think it's come out of a medium wave. It's a medium wave antenna. Still got some glue on it, which was holding the coils on for the antenna. So if we slide this in through there, it's not going to do it. It's too big. So what if we wrap it around and see what happens? Obviously, it's very impractical. Not practical at all. What are we down to? S6. So let's see if we can get it down to 0. I say this is totally impractical. It's just a bit of fun. I will have to sort the microphone out at some point, but I've started using the original microphone, the one I bought. It doesn't seem as though we're going down any less than the 6 and an S6. Yeah, it did make a little bit of a difference. Let's try the tighter fitting one. This one's quite tight fitting. There we go, it's an S6. That's quite tight fitting, our one is. I've got another one here, which is quite tight fitting. That's gone down to an S5. So let's take this out and see what it goes up to, if anything. S7 from a piece of bar. You just wrap your wire or whatever, or your coax, whichever the case may be, around here. So we'll have to sort the microphone out at some point. Not sure what is wrong with it. But obviously it could be screening. It could be the screening on the microphone could be rubbish. But this one seems to work quite well. If I can get it back on there. S8. They're very handy things to have. S9 Plus. Doesn't seem to make any difference where I put it around here. But the benefits of ferrite rings, of clip-on ferrite rings, ferrite bars. Of course, you can get the rings as well. I think I've got some of them here. Let's have a look. Yeah. Of course, you can get them in this style as well, where you pass the wire through, and these are the sort which you get in balance, like 4-to-1 or 9-to-1 balance, that sort of thing. Of course, you know, putting that on here would be, you know, a bit stupid, really. You can also get them in tube form like this. This is a tube form like that. More common like this, which is a matching transformer for an amplifier. You'd have the 2 transistors, one either side, and this is the transformer then, which would sort of match the impedance of them. So the impedance of the 2 transistors, it would match them for the impedance for the antenna, that sort of thing. Normally I think they're 4-to-1 normally, but you can get them in different styles depending. And the mix of the ferrite, what sort of mix it is, governs the frequency range. This is HF, but you could have another one that could be VHF. So there we go. Anyway, bit about ferrite rings. Usefulness, always handy to have. I've got quite a lot of them here. I always keep them whenever I see them on anything. I always take them off. Old computer leads and things, they have them on there. I might have one, in fact. This one came off a monitor. This one did. I cut it off a monitor and removed the cable. It's plastic. It's like a plastic rubber or a rubberized. It's harder than rubber, but it's not as hard as plastic. So you've got this type as well. It's got a piece of ferrite in there, or 2 in fact. But look at it. Not look down the middle. No, 1. So this has got a ferrite tube that the monitor cable would go through. But anyway, if you see them, always pick them up because they're very, very useful. So yeah, now I've got the microphone here. I might have a look and see if I can figure out what is causing it. So if I do, then I shall I'll do a quick video and show you what it was. Hello, so I've got the microphone apart. It's that DTMF microphone. So yeah, you can see there's ICs on here, generates the tones and whatever. So this is basically the reason why it's generating all the rubbish it is, I suppose. A bad circuit design, I suppose, because you know, if it was designed properly, then it wouldn't be doing what it's doing. So the power comes up the lead from the radio to the socket, and then it comes along this track here. There's a decoupling capacitor, and then it comes to this pin here. I've put this ferrite ring in. I put this piece of ferrite in here, or this ferrite coil, because there was just a jumper wire from there to there. There was just a jumper wire. So if I disconnected that wire, then obviously there was no power to the microphone, and it was quiet. The up and down stopped working now, but the TX still worked, the transmit still worked, but every other function stopped working. So I put the ferrite ring in place of the jumper wire, and it's cut the noise down slightly, not a lot, slightly. And no matter what I seem to do, I've added decoupling capacitors and things here and there just to try it, and yeah, it doesn't seem to do an awful lot. Cut it down a little bit, but virtually nothing. So that's what it is. If I disconnect the lead, I thought it might be the lead, the screening on the lead might be crap, but that doesn't seem to be the case, because it's plugged in now and it's fine. So if we go back to the microphone here, awkward to do one-handed. And there we go. It's back. It's back. So it's not the lead, it's the microphone itself. Now I did initially think I'll swap the leads over. I'll try the lead from the Yaesu microphone. And you would think, yeah, okay, give that a go. But you've got to be careful. If you look at the, let me put the camera on the stand. If you look at these leads, the ends, you can see they're the same. You've got red is the very first wire. I don't know if it's focusing properly on there. Let's have a look. So red is the very first wire, and black is the very last. So black is there, red is there, red is there, and they're the same. They're the same wires all the way along the both. So you can interchange these. You can swap these around, whichever one. This end can go in the radio, or this end could go in the radio. And you think, yeah, okay. So I'll swap this lead with this one, but you can't do it for the fact that they are not the same. If you can see, red is the first lead on this one. It's not red is the first one on that one. So you can't swap them. You can't also mix them up. You can't put this one in the radio and this one in the mic, or this one in the radio and this one in the mic. You can't do it. So you can't swap this lead. It is what it is. So this is the end that goes in the microphone, and this is the end that goes in the radio. If you swapped it around, then there's a possibility of damage the radio, because obviously there's voltage running up the lead. Who knows? And I'm not prepared to try it. So that's out the question. So that really can't be done. So yeah, that's just how it is. Cheap and cheerful microphone. You think you're getting a good deal because you're saving 15 quid, and lo and behold, you end up with a piece of junk. You end up with a piece of junk. I said it works, but it's pretty rubbish. So the only way to stop the noise really is to disconnect the power, and all functions stop other than the transmit. The noise I get are on specific frequencies, so it'd be dotted around. Like, it's one there, not as strong. You can hear it. One there. The strongest one is the one we just saw, but there. There's one. I know it does it on 28 as well, but I've not tried it on any other band. So yeah, there we go. Not a lot I can do with it, other than sort of like, well, just disconnect the power to it, and it then just becomes a standard microphone. And if that's the case, you may as well just get a standard microphone. So there we go. A piece of crap. I don't know if it's got a. I don't know if it's got actually a model on the back of it. Anything on there? Nothing at all. It's a big bulky thing as well. So there's no model apart from what it says on the B7487. That's about the only thing it says, which could mean anything. So there we go. Well, thanks for watching. I'll put it back together, and it'll just be a spare. It won't be used for anything. of any use, it'll just be a spare.